So this is chapter 11 and section 1. And if you have the printed out notes for chapter 11, you will notice that these are very short sections. So each of these videos will be pretty short. This first one is just an introduction to sequences, which is really just a list of numbers in a pattern. And so we will be kind of exploring that here. There are two types of sequences, infinite sequences and finite sequences. Excuse me. So an infinite sequence is one that doesn't end. It goes on forever. There's no last term. A finite sequence ends. It's a limited number of terms that we're looking at. There are also two types of formulas, recursion formulas and explicit formulas. A recursion formula has an a sub n minus 1 in it. We need the term before in order to find the next term. So for example, you might have something that says a sub n is equal to 2 times a sub n minus 1 plus 5. And so this would be using the term before. So if I wanted to find like the sixth term, then I would need 6 minus 1 is 5. I would need a sub 5, the fifth term, in order to find a sub 6. The other type of formula is called an explicit formula. Some examples of explicit formulas down here below where we just have an n in it, or we have n minus 1 or n's here. Those are all examples of explicit formulas. Whereas here, I have that a sub n minus 1. This would be a recursive formula. Okay. Now, kind of going back to this box I skipped over, we also have something called a factorial. That's where you see this exclamation point in the problem here. So if I have something like 5 factorial, what that means is I have 5 times 4 times 3 times 2 times 1. Well, 5 times 4 is 20, times 3 is 60, 60 times 2 is 120, 120 times 1 is 120. So that's what 5 factorial means. So if you have a number with an exclamation point, this is what it's telling you to do. Now there's a couple here that we have to define. 1 factorial is just 1. And 0 factorial we also define as 1. If you've ever done permutations and combinations in those formulas, you see why we have to define 0 factorial as 1. All right, let's do a couple examples here. So it says write the first 4 terms of the sequence. So I want to find a sub 1, a sub 2, a sub 3, and a sub 4. And plugging in 1 for n, I have negative 1/3 to the first power, and that would be negative 1/3. Negative 1/3 squared would be positive 1/9. Plugging in 3, negative 1/3 times negative 1/3 times negative 1/3 would be negative 1/27. And then a sub 4, negative 1/3 to the fourth power would be 1/81. All right, on to the next example. It says a sub 1 is 2, and then they still want us to find the first 4 terms. So we want a 1, a 2, a 3, and a 4. And we were given a 1 is 2. So in order to find a sub 2, I need 2 minus 1 is 1, so a sub 1. A sub 1 is 2, so 2 times 5 is 10. To find a sub 3, 3 minus 1 would be 2. A sub 2 is equal to 10. 10 times 5 is 50. To find a sub 4, 4 minus 1 is 3. A sub 3 is equal to 50. 50 times 5 is 250. Okay. The next one, again, we're finding a 1, a 2, a 3, and a 4. And plugging in 1, 1 minus 1 is 0. 0 factorial, as we saw above, is defined as 1. 1 times negative 2 is negative 2. And a sub 2, 2 minus 1 is 1. And then 1 factorial is defined as being 1. 1 times negative 2 is again negative 2. And then 3. 3 minus 1 is 2. 2 factorial is 2 times 2 times negative 2. So negative 2 times 2 times 1 is negative 4. And then plugging in 4, 4 minus 1 is 3. That would be 3 factorial times negative 2. And that would give us negative 12. Okay. In the next example, we have two places where we're plugging in n. So I'm still finding a1, a2, a3, and a4. But plugging in 1 here, 2 to the first power is 2. And plugging in 1 here, 1 cubed is 1. 2 over 1 is just 2. Plugging in 2. 2 squared is 4. 2 cubed is 8. So that would be 4 over 8, which is 1/2. And then plugging in 3. 2 cubed is 8. And 3 cubed is 27. So we get 8 over 27. And then 4, 2 to the fourth power is 16. And then plugging in 4 here, 4 cubed is 64. And 16 over 64 is 1/4. All right. So this last example here is having us simplify a factorial. This is not a sequence. This is just evaluating these factorials here. So 20 factorial would be 20 times 19 times 18 all the way down to 1. And I think this pen might be dying here. Let me switch pens. So we have on bottom 2 factorial, which is 2 times 1. And then we have 18 factorial, which is 18 all the way down to 1. So if I were to write out all of those numbers, the ones would cancel, 2s, 3s, 4s, all the way to 18. So rather than writing it like that, what we can do is we can write 20 times 19 times 18 factorial. And then on bottom, 2 times 1 for that 2 factorial, and then the 18 factorial. So 18 factorial over 18 factorial, those cancel out. And then on top, we have 20 and 2. Those can reduce, and that can become 10. And so 10 times 19 is 190. And that would be our answer. Okay. And that actually brings us to the end of section 1.